Okay, so let's take a look at this first question here. Sorry, I forgot to label these. Let's say we have a regular hexagon where the sides, go ahead and just label this as 10 meters. It's regular, so every single side is going to be 10 meters, right? 10, 10, 10, 10, 10, 10, 10. And let's go ahead and just say the height of this hexagon is 11 meters. 11 meters, right? You got 11 meters here. So we're going to unwrap this hexagon to take a look at the total surface area. Again, we're painting this entire thing here. So we unwrap it, we get this net. Again, this is the net. So we've got 10, 10, 10. Again, these are all 10s. 10, 10, 10, 10, 10, 10, 10. Okay, and then the height of this guy is 11. Okay. And again, we got the hexagon, the regular hexagon, each with 10. Okay, so let's imagine, what is the surface area again? It's if you dip the whole thing in paint or chocolate or whatever, what would be covered? Again, it consists of the lateral area. What's the lateral area? It's like the sides. It's like the rooms of the house. If this was like a room, it's just the side parts on the edges here. On the net, it's this part right here, this whole kind of middle part, the lateral area. It's the unwrapped sides here. And then plus we want to add on the two base shapes. We call this 2B. This is like the area. Again, this is the area of the base shape. Okay, this is the area of the base shape. And that's, again, the big B, we call that the area of the base shape. We got two of them. We got one hexagon on the top, one on the bottom. So again, I've got one hexagon up here and one down here. And that's what these guys are. Okay, so I'm going to add on both hexagons. Okay, so we don't fully have a formula for the lateral area, but we can just calculate it by hand. Let's look. What is this length right here? Well, it's just 10 plus 10 plus 10 plus 10 plus 10. It's just basically 10 times 6. It's 60, right? It's just a rectangle. 60 times 11, right? Our lateral area is just base, which is 60 times 11. 60 times 11 is 660. 660 meters squared. So this guy right here is 660 meters squared. And then we need to add on the two base shapes. So again, this is our big B here for the hexagon. So I'll just say the area of the hexagon. Now again, hexagons, what's the area formula for hexagon? Remember, it's 1/2 apothem times the number of sides times the length of each side. Okay? So we got to do a little bit of work here. Remember, this is a 10, right? This is a 10 here. Let me erase the big B just for a second. So we're going to start and put a little dot right here in the center. And just like we do, we're going to make a triangle, draw the apothem, figure out the angle, special triangles are awesome. Let's take 360, divide it by 6. We're going to get 60 degrees. So again, for each of these guys, you don't have to draw them, but it's 60, 60, 60, 60, 60. Take 60, cut it in half again. We're going to get 30. So this right here is 30 degrees. It's a 30, 60, 90. Okay, and remember, this is a little half piece right here. This is not 10. This is a 5. Okay, so this is our shorty. This is our shorty. That's a 5. It's a 30, 60, 90 triangle. So what's this apothem? 30, 60, 90. Long equals shorty root 3. This is a 5 root 3. 5 root 3. Of course, you could use trigonometry as well. 5 root 3, you should get something like 8.66. Okay, 5 root 3. So the area of our hexagon is 1/2 the apothem, which again is 5 root 3. 5 root 3, or 8.66. If you want to use trigonometry, times the number of sides, which is 6, times the length of each side, which is not 5. Remember, it is 10. Okay, so before we just punch this in, let's just simplify. 6 times 10 is 60. Half of 60 is 30. 30 times 5 root 3 is 150 root 3. 150 root 3. So we're going to get 150 root 3 meters squared, or if we punch that in our calculator, about 259.81 meters squared, right? That's one of these hexagons. That's one of these hexagons. So I'm going to take that, I'm going to plug it back in over here. All right, that's one of these guys. So now let's back up. So again, the lateral area was the 660, right? This thing right here, plus 2 of these base shapes here. 2 of these 150 root 3s. I'm just going to use 150 root 3. You have 150 root 3 here. You have 150 root 3 over there, right? This is the 250 root 3s. So total, we're going to get 660 plus 2 times 150 is 300 root 3. 300 root 3. Now, we cannot combine these. You cannot combine a root 3 with a regular number. So I'm just going to punch that in my calculator. So 660 plus 300 root 3 is going to give us 1179.62 meters squared. I mean, you could actually leave it like this. They're both correct. But 1179.62 meters squared. Okay, next up, let's say we have a cylinder. Now again, even though it's made up of circles, it's actually still the same thing. Let's say, again, sorry, I forgot to fill in the numbers. Let's say the radius for this guy is 4 meters. Let's just put this 4 meters. Let's say the height is 10 meters. 10 meters. It's pretty much the exact same thing. So let's say, again, we take this guy and we unwrap it. So again, what is this distance around here? That's still just this thing right here, right? So this thing right around here, that's the perimeter of this guy is just the circumference of the circle, right? So it's not 4 necessarily, but it's just, again, it's just the perimeter of the circle, which again we call, right, this is the perimeter. Just like back for this one, right, we took this guy, this whole thing right here, this is just the perimeter, right, this thing right here, this is the perimeter, 60, okay? Same thing, we're just taking the perimeter, except for a circle we call it the circumference. Again, the circumference is 2 pi r. That's the only difference, right? We take this guy and we unwrap it and we get the perimeter slash circumference, right? This is the perimeter, but we actually just call it the circumference, okay? So our surface area for a cylinder, it's very similar. Our surface area equals the lateral area plus the 2 bases, the 2 base shapes, okay? So our lateral area, what's the lateral area again? It's this, all this stuff kind of on the sides, right? It's this whole, like if it was a can, it'd be the side of the can. When you unwrap it, it's this thing right here. And then the 2 bases, right? It's just the circle is the base on the top, circle is the base on the bottom. I have 2 circle bases, one on the bottom, one on the top, right? That is my 2, I'm just gonna use a big B for that, big B for base shape. Big B here, big B here. So I have 2 big Bs, okay? So let's talk lateral area first. This is the lateral area. So again, it's just a rectangle when you unwrap it. It's just a rectangle. So again, what is the width of this rectangle? It is just the circumference, right? Just unwrapped, and that is 2 pi times the radius. Now, what was the radius again? The radius was 4, 2 pi r. Okay, and then what is the height? It's just this guy right here, which was 10. I think we said 10. Okay, so our lateral area is just a rectangle. It's just base times height. It's just 2 pi times the radius, which is 4, 2 pi r, times the height, which is 10. Okay, so that all together, let's see, we can do that in our head. 2 times 4 is 8. 8 times 10 is 80. It's just 80 pi meters squared. 80 pi meters squared. Now we're not even going to round it. We'll just say 80 pi, right? 80 pi meters squared, right? It's just a rectangle, okay? And then for this one, again, the area of the circle is much easier. Now, again, the formula is different. We're not going to use 1/2 ANS like we did for a hexagon. We're going to use the area formula for a circle, which is just pi r squared. So one thing to remember is when you're finding the area of this base shape, it's a different formula. If it's a circle, it's pi r squared. If it's a hexagon, it's 1/2 ans. For a circle, it's much easier. Pi times 4 squared. 4 times 4 is 16 pi. So again, we got 16 pi area here on the bottom and 16 pi on the top. We have two 16 pi's. So we're going to take this and plug it in right here. Okay, so our total surface area is the lateral area, which was, again, this 80 pi, plus 2 of the 16 pi's, right? 16 pi on the bottom, 16 pi on the top. So we combine that, we get 80 pi plus 32 pi. And since this is pi and pi, we actually can combine this. 80 plus 30 plus 2. 80 plus 30 plus 2, that is 112 pi meters squared. And you can just leave it like that if you want. If you want to punch in 112 pi, you're going to get about 351.86 meters squared. Okay, so now we're starting to get a little basic feel for this. Remember, the lateral area, no matter what, even if it's a circle, when you unwrap it, it's just a rectangular shape. All right, so to get to this formula that we're talking about, what is the surface area formula? Again, all we're going to figure out is it's the lateral area plus these two bases. The key is, what is the lateral area? How do I get this rectangle here? Well, as we can see, it's basically just the perimeter of whatever this shape is unwrapped, right? It's just the perimeter times the height. The perimeter times the height gives the lateral area for no matter what, whether it's 5 sides like this, 5 sides, again, we unwrap this perimeter, there it is, perimeter times height. That gives us this rectangle. Even for something like a cylinder, I have a cylinder right here. Again, how do I get this? It's just the perimeter of the circle, which we call the circumference, right? The perimeter is 2 pi r times the height. Okay, so all right, so let's write that formula down. So again, our surface area for any prism is, we're going to say surface area equals lateral area plus the area of the two bases. And again, one key thing to remember, again, this is the area of the base shape. And again, the formula changes. I'm just going to write that. The formula changes. It depends on what shape it is, right? If this is a rectangle, it's base times height. If it's a triangle, it's 1/2 base times height. If it's a pentagon, it's 1/2 ans. Okay? And then the lateral area. What is the lateral area? This thing that we've been finding. Again, what the lateral area simply is, it's the perimeter times the height. And again, the perimeter is the perimeter of the base shape. Right, that gives you that nice rectangle. So it's the perimeter times the height plus 2 times b. And this is our surface area. Just box that up. For the cylinders, right, that's anything with a circle base, it's actually the exact same thing. Our surface area equals our lateral area plus the two bases, right? The only difference is, right, because this is a cylinder, it's always going to be a circle. So I'm just going to rewrite this in the exact same way. So just like we had over here, we have the perimeter times the height plus the two bases. One thing I'm going to do is, because it's a circle, I'm going to write pi r squared instead of the base, right? Because it's always the same formula. And then instead of the perimeter, right? Remember, perimeter for a circle, perimeter equals circumference, which we know the formula is 2 pi r. Sorry about the pen there. 2 pi r. So I'm going to rewrite this just as 2 pi r times h plus 2 pi r squared. But again, these formulas are the same. They're the same. Okay, so let's finish up with these three. Find the surface area. So instead, we're just going to jump right to this formula. So again, this is a triangular prism for number 5. So our surface area equals the lateral area plus the two bases. Again, our bases is this triangle here and this triangle back here. This is our big B. This is our big B. We're not going to draw a net. But instead, now we realize that the lateral area, this thing right here, is really just the perimeter times the height. It's the perimeter of the base shape times the height. Okay? So let's just figure out, what is the perimeter? Well, it's this 13 plus this 10 plus this 13. The perimeter equals 13 plus 10 plus 13. 13 plus 10 plus 13, that is 36 meters. So just imagine, again, this is unwrapped, and you can kind of see it as one big triangle there. It is the perimeter, which is 36, times the height. What is the height? That's the distance between the two bases. That is 18. 36 times 18. Okay? Plus 2 times the area of the base shape. So what is this area right here? Well, let's just figure out the area of this triangle right here. What is the area of this triangle? Let's remember again our formula. It is 1/2 little b, little base times height. Okay, I'll do a little work here. So our base is 10. Again, our height is this guy right here. We can always draw it in even though there's nothing written here. Okay, what is this guy? Well, first off, if we do this little half piece, this is a 5. Okay, this is a 13. This is a 13. And so what would the height be? Well, this height right up and down. Again, if I use the Pythagorean theorem, 5 squared plus something squared equals 13 squared. If we remember carefully, that's a Pythagorean triple. I don't even have to do the Pythagorean theorem. This is 12. So our height is 12. So the area is 1/2 the base, which is 10, times the height, which is 12. 1/2, 10 times 12. I'm going to half the 10. That's 5. 5 times 12 is 60. 60 meters squared. So we have 60 meters squared in the front, 60 meters squared in the back. So I'm going to go ahead and plug this in over here. So again, our lateral area is 36 times 18, which is 648, plus 60 in the front, 60 in the back. That's 120. Combine that, that is 768 meters squared. That's our surface area. I'm just going to double box that. All right, so next up, number 6. Okay, right here, again, we've got, this is a 1, 2, 3, 4. Ooh, this is a pentagon. This is going to be a fun one. This is a pentagon. So we got a little bit more work here today. So surface area equals lateral area plus the 2 bases. But what's the difference here? The base is here. We got a pentagon in the front, pentagon in the back. So our bases are pentagons. We got to be careful. Okay? Again, our lateral area is all this stuff in the side. It's all this stuff in the side here that we're basically just going to unwrap. So formula again is the lateral area is just the perimeter of the base shape times the height. So this is 6, 6, right? These are all, remember, we can assume these are all the same. Everything here is a regular polygon. So we have 6, 6, 6, 6. So our perimeter is 6 plus 6 plus 6 plus 6. Basically 6 times 5, right? 6 times 5, we're going to get 30. 30 centimeters. How high is that stacked up? Our height, what's the distance between them? It is 15, right? Each of these are 15. So our lateral area is going to be 30. The perimeter is 30 times the height, which is 15. Now, we have to do a little bit of work, though, to find the area of one of these guys, one of these big B's. Let me go ahead and erase this, first of all. Okay, so remember, the formula's changed. It's not 1/2 base times height anymore. So again, now our formula is 1/2 A times N times S, apothem, times the number of sides, times the length of each side. I know it's a little bit small, I apologize, but let's put a big dot in the center, and oh, you thought you were away from it, but no. Make a triangle, draw the apothem, figure out the angle, special triangles are awesome. Let's take 360 divided by 5. We get 72, but don't forget to cut it in half again. That's 36 degrees. 36 degrees, right? Now, again, this little half side here, this is a 6, so this is a 3. So again, we're going to have to use SOHCAHTOA, right? This is our opposite, and this is our adjacent, right? This is our SOHCAHTOA. So we're going to have to use the tangent ratio. We have to use the tangent ratio. Sorry, running out of space over here, so let's come over here. The tangent ratio at 36 degrees equals opposite over adjacent, and that's the apothem. I'll just call it A. You can call it X if you want. All right, tan 36. I'm going to punch that in my calculator, tan 36. So the tangent ratio at 36 degrees is about 0.726, or I'll just say 0.73. All right, so we could say 0.73 over 1, or tan 36 over 1 equals 3 over the apothem. Okay, let's go ahead and cross multiply. So we're going to get 3 equals 0.73, which is tan 36, times the apothem, which means we're just going to have to divide both sides by 0.73. Okay, so our apothem is 3 divided by 0.73, or 3 divided by tan 36. So if I do 3 divided by 0.73, we get about 4.11. Our apothem is about 4.11, or about 4.13 if you didn't round it, which is even better. Okay, so let's plug this in. So our area is 1/2 the apothem, let's just round it to 4.11, times the number of sides, which is a pentagon, which again is 5, times the length of each side, which was 6. So we can just punch this in our calculator, or we can just simplify. Let's see, 5 times 6 is 30. Half of that is 15, so 15 times 4.11. 15 times 4.11, it's about 61.65. About 61.65 centimeters squared, or about 61.95 if you didn't round it. Okay, so I got 61.65 in the front, 61.65 in the back. Let's go and plug this in over here. So 2 times 61.65. Okay, so 30 times 15 is going to give us 450, plus 2 times 61.65, that's 123.3. So again, we got 450 for the lateral area plus 123.3. Add them all up, we get 573, approximately, right? Approximately 573.3 centimeters squared. That's our surface area. Okay? Lastly, again, we could call this a circular prism if we wanted to. It's just a cylinder. I've got a base on the front. I got a circle on the top. I got a circle on the bottom, but it's the same formula. Same formula. Last one. Surface area equals lateral area plus the two bases, but again, these are just circles. Okay, again, the lateral area is just the perimeter times the height. It's just the perimeter, this guy right here, times the height, which is this guy right here. The only difference is we don't really call it perimeter, right? Perimeter is just the circumference, which is just 2 times pi times r, and it appears the radius is 3. 3, right? That's all this guy is, 2 times pi times 3. So that is 6 pi, right? 6 pi. So our perimeter is 6 pi, right? Again, that's just the circumference, 6 pi times the height, which is 7, plus 2 times the area of the base. And again, the formula is different. For this guy, it's not 1/2 ANS. It's not base times height. It's not 1/2 base times height. It's pi r squared. So you just have to adjust your formula. This one's much easier. Pi times 3 squared. 3 times 3 is 9 pi. So 9 pi centimeters squared on the top, 9 pi centimeters squared on the bottom. So total, I'm just going to rewrite this, 18 pi. Okay, so we've got for the lateral area, 6 pi times 7, that is 42 pi. 42 pi for the lateral area, and 18 pi for the top and the bottom circle there. Combine pi with pi, 42 pi plus 18 pi, that is 60 pi centimeters squared. You can leave it like that, that's fully accurate, or if we round it, it's about 188.5 centimeters squared. I'll just double box that. Okay, that's it.